guys. So in this video, well actually before I get into this video, so this is going to be about inscribed stuff today, inscribed in a circle. Just a reminder that this video is optional, that the suggested plan for our district and for our school is to use the Learning at Home website. This is really just meant to be as something extra in addition to that if you feel like you need these extra notes, or if you like, having the notes that the way that we do it in class. Also, so some suggested materials for what we're going to be doing today for these notes. Notebook or notebook paper, pens, pencils, or markers. I'm going to be using black, green, pink, orange, and blue markers. And then I'm also going to be using some highlighters, pink, green, and orange. And then I'm going to be using a compass for me to trace the circles. This is a safety compass. I've talked about in a previous video how to use these to draw circles. And of course, if you don't have one of those, then you can use like objects that you can find around your house to trace them. So here's some examples of about the size that you're going to want today. So this is just like, this is just a little hair product that I have. And so this is about the size. Oh, that's kind of hard to see. Let me get a scratch paper so you can see about how big it is. Okay, so this is kind of the size that you're going to want. Think about that size. And or I also have like an Advil bottle. Works. Like a little medicine bottle. I have one of these. It's about the size that you want. Or even, this one's a little bit smaller, but, glue stick. I'm not being very careful tracing here, but those are about the sizes of circles that you're going to want for this lesson today. Okay, so our notes today are going to be 2 pages. I'm continuing on in the same notebook that I did from the last video, and I actually went ahead and I put in page numbers. So I'm just going to number it based on the particular unit that we're in. So like this is page 1 for circles, the first page of that unit. This is the second page of that unit. And then today we're going to do pages 3 and 4. Okay, so to start off, today's lesson is all about stuff being inscribed in a circle. So let's talk about what it means to be inscribed. And I'm going to show you, I have a PowerPoint, so I'm going to kind of be going through this today too. So to inscribe, it means to draw something inside of another shape with every vertex touching the edge of a shape. And here's 2 examples. So here's a triangle inscribed inside of a circle, and here's a pentagon inscribed inside of a circle. So you can see how the shape, every vertex is touching the edge of the circle. Okay, and that's what it means to inscribe something. So I like to say inscribed means inside. So you know that that shape has to be drawn inside of the shape. Okay, so one of the first things that we're going to put in these notes today is we're going to write down what that means, what to inscribe something means. Okay. So inscribe means to draw something inside. If you want to like bold that in, because inscribe means inside. Okay, another shape. With every vertex touching the edge of the shape. Okay, so I want to show you some examples of things that would be inscribed and some things that would not be. So on this slide, it's asking us, is it inscribed? And then we have a bunch of different things. So I would actually recommend that you pause the video right now and see if you can figure it out yourself before I go in and I tell you which ones are and which ones aren't. So I recommend pausing the video, go in yourself and write down which ones are inscribed and which ones are not inscribed, and then unpause when you're ready to check it. Okay, so if you're ready to check, then I'm going to get my pen here. Let's see, I want to have a pen, and let's do pink, because I like pink. Okay, so if it's inscribed, that basically, you know, we're trying to make sure that all of it's inside of the circle, which is true for all of these, but also we need to make sure that every vertex is touching the edge. So this one, you have 3 vertices. They're all touching the edge of the circle, so yes, that's inscribed. Here we can clearly see that none of these vertices are touching the edge of the circle, so no, that's not inscribed. Here we have a square. Only 2 of the vertices are touching the edges, the other 2 are not, so no, that's not inscribed. This one is probably the weirdest looking one, so this is actually an angle. Okay, so we have a vertex here, a vertex, or well, not a vertex, but a point here, a vertex here, and another point here. The vertex of that angle is touching the edge of the circle, which means that yes, this is inscribed. This is an inscribed angle. Okay. Now this one, if you look at this angle, the vertex is touching the center of the circle, these 2 points on the edge, but the vertex is not touching the edge. This is a central angle. Central angles are not inscribed. And then last, we have this quadrilateral. Each point on this quadrilateral is touching the edge of the circle, which means that yes, that is inscribed. So in your notes, we're going to put down 3 examples. 2 examples of stuff that are inscribed and 1 that's not. So if you want to get your little circle to trace, okay, I'm going to come in here and use mine. Let's see. So on my compass, you can also use this part to draw smaller circles if you don't want to use this part. So I'm going to kind of put my, let's see, scoot this over. Put this here, and let's use this size. Why not? Okay. We'll scoot over a little bit. Another one. Okay. And another one. Another one. DJ Khaled. Okay, so, all right, so I want to do 2 examples of something that is inscribed and 1 example of something that's not inscribed. So let's do an inscribed triangle for the first one. So just kind of put your 3 points on here. And then, you know, I like to be nice and neat, so I'm going to use a straight edge to trace my lines. Okay. So that's an inscribed triangle. Let's do an inscribed angle. Okay. So 3 points again, but we're just gonna connect it like this. So we've got something here, and we've got something here. So there's our inscribed angle. And then this is gonna be an example of something that's not inscribed. And I'm gonna use a central angle as the example of something that's not inscribed. And then this is where our green and pink markers are going to come in. So I'm going to put a check next to the ones that are inscribed, and then an X. Okay, this one's not inscribed. Okay, because its vertex is not touching the edge of the circle. Okay, so inscribed angles actually have some special properties. So that's what we're going to look at next, is the special properties of inscribed angles. So first we want to go ahead and define what an inscribed angle is. Okay, so inscribed angles. Okay, this is an angle formed by 2 chords. So if you'll remember from the last video, a chord is a line that, or a segment that touches one edge of the circle to the other edge of the circle. So two chords whose vertex lies on the circumference of the circle. Okay. All right, and then I want to do another 3 examples here of what inscribed angles are and what they aren't. I don't think I had any more. Did I have more examples on my PowerPoint? Talk about inscribed angles. Yeah, okay. So, no. Okay. So then, let's see. I'm going to make my circle a little bit smaller this time just because I want to have more room. Okay, so let's do this circle here. And this one here. And what did I use to? There we go. Love that tool. So handy. Okay. So again, this right here is what an inscribed angle should look like. The most important thing is that this vertex is on the edge of the circle. I'm going to do 2 examples of what is not an inscribed angle. So not an inscribed angle would be something like this, okay, if it was just floating out in space like that. And another would be something like this, okay, a central angle is not an inscribed angle. So again, we'll put our check here, okay, that one is yes. And these are no, not inscribed. Okay, vertex is not touching the edge. Okay, so for this next section, what we're going to talk about is called the inscribed angle theorem. Okay, so before we write down what this theorem says and what it is, I want to kind of go through almost an informal proof of how this theorem works and why, or what it comes from. Okay, so let's say that we knew, okay, so we have this line BC. This is the diameter of the circle. This point D right here, okay, that is the central angle. Let me use green for that. Okay, click. Okay, so this is our central angle. And let's say that we know that the inscribed angle, this one here, has a measure of 30. Okay, and we want to figure out what is the measure of this angle D. So we know the inscribed angle. We're trying to figure out what the measure of the central angle is. Okay? All right. So, erase that. It's kind of messy. All right. So first thing I want to point out, use that color. Okay. So here's some kind of hinting questions right here. So the first thing it asks is, what kind of triangle is ADB? So 2 things. This line BD right here is a radius because it connects the center of the circle to the edge. Okay. Also, this line AD right here, that is also a radius. All radiuses or radii inside of a circle are the same length. I mean, by the definition of what a circle is, all radii have to be the same distance from the center, so that means that these 2 sides are congruent, which means that this is an isosceles triangle. Okay, now here's where we're going to bring in some stuff that we know about isosceles triangles. So we know that in an isosceles triangle, the base angles are congruent to each other. So if that angle is 30, okay, this angle right here is also 30. We also know that angles in a triangle have to add up to 180 degrees. So we can solve for this angle right here by using the 180 degrees in a triangle. So if we add 30 plus 30, okay, that's 60. 180 minus 60 leaves us with 120. Okay, so that's the measure of this angle right here. Okay, that's that 120 degree angle. Now, why does this help us? Because, actually, let me get a highlighter. Okay, these two angles right here form a straight line, right? And straight lines are always 180 degrees. So that means that if this angle right here is 120, this is getting messy. Erase some of this. Okay. So we know that this angle is 120. We can subtract from 180 to get the other one. Okay. 180 minus 120 leaves us with this angle being 60. Okay, now I want you to stop and compare. This is our central angle right here, and this is our inscribed angle right here. What is the relationship between those two numbers? And if you stop and think, okay, you'll realize that the inscribed angle is half of the central angle. 30 is half. 30 is half of 60, which means that our inscribed angle B is half of that central angle D. We can also say that it's half of the arc, okay, that's in this picture. Since central angles and arcs are the same degree, what we can apply to the inscribed angle and central angle, we can apply with the arc. So we can also say that angle B is half of arc AC. Okay, half of 60 is 30. Okay, so here's what we're going to put in our notes. Okay, so the inscribed angle theorem says that the measure of the inscribed angle, which we'll call x, is always half the measure of the central angle, which we'll call y. Okay. So the measure of the inscribed angle, which we'll just call x, is always half the measure of the central angle, which we'll call y. Okay? Or we can also say, so it is half the measure of the central angle or the arc, okay, AB, that it intersects. Okay, so we're going to draw a picture here. Okay. So I'll get my compass out. Let's see. Let's put our center here. Make this one a little bit bigger. Okay. All right, and then we'll have our central angle here. Okay. And then the inscribed angle should be intersecting the same points that the central angle intersects. Okay? All right, we'll call these points A and B. This is Y, our central angle, and this is X, our inscribed angle. And I'm also going to use our highlighter to highlight some things here. Okay. This is fine. So we'll highlight the central angle and the arc with orange. Okay. Hopefully it doesn't bleed too bad. And we'll highlight the central angle with pink. Or sorry. We'll highlight the central angle with orange. We'll highlight the inscribed angle with pink. Correction there. Okay. All right, so that's our inscribed angle. Okay. And let's see here. Let's say that x is equal to 1/2 y, or you can also say that x is equal to 1/2 of the arc AB. Okay, and you don't necessarily have to write this down, but this works in reverse too. Heck, why not? We can just write it down. So let's say that I was solving for y. Okay. So if x is half of y, then y is also double x. Okay, so y is equal to 2 times the inscribed angle. You could also say that AB, the arc AB, is equal to 2 times the inscribed angle. Okay, so it goes either way. Either you're given your inscribed angle and you can multiply by 2 to get the central angle or the arc, or you're given your central angle or arc and you divide by 2 to get your inscribed angle. Okay, so I'm not going to put these examples in the notes, but you could always put them on another page if you want. I know that we're going to be writing on 3 and 4. If you wanted to put them on page 5, you could do that. Or you don't have to write them down and you can just watch. That's up to you. Okay, so here's one example. Let me get my little stylus here. Okay, so let's say that we knew that CBD, this angle here, let's use our freaking colors. Okay, so let's say that we know that this was 45 degrees. Okay, and we were trying to find the measure of angle CAD, so that's this angle right here. Okay, pretty easy. The measure of this central angle is going to be twice the measure of whatever the inscribed angle is. So 45 times 2, which I believe is 70. Nope, sorry, 90. This is why I double check. Okay, so 45 times 2 means that that angle is 90 degrees. Easy peasy. Okay. In this example, we're told that CAD, this angle right here, CAD, is 70 degrees. And this time we want to find the measure of CBD. So what's this angle? Okay, well, this central angle we know is twice the measure of whatever the inscribed angle is. So going this way, going from bigger to smaller, 70 divided by 2 is equal to 35. Okay. So that's the measure of that angle CBD. Scroll. Okay, there we go. All right, last example. Let's say that there's no central angle shown this time. It's just the arc, which that's going to happen quite often. They don't always put a central angle in there. Sometimes they might just put the arc. But remember that it's the same thing. Okay, if that arc is 100 degrees, the inscribed angle is going to be half that. So if that's 100, then that angle is going to be 50 degrees. 100 divided by 2 is 50. Okay? Okay, I have these 2 other slides here. I'm not really going to write these in the notes because they're just so obvious to me. But just FYI, a corollary to this, and a corollary basically means, so our theorem was the inscribed angle theorem. Okay, So what a corollary is it means that, okay, we already proved this theorem. This next piece of information is just something that follows from this theorem, okay? So a corollary is something that follows from something that was previously proved, a previously proved theorem. So what this says is that it says inscribed angles that intercept the same arc are congruent. So basically, you know, if this arc is, these are all 80 degrees, okay? And then you have 3 different inscribed angles, but they're all intersecting the same arc, the same 80-degree arc, okay? Then that means that all of those angles would be 40 degrees because they're all going to be the same measure since they're all half of the arc that they're intersecting, okay? This is true as long as the inscribed angle lies within the major arc. So remember, a major arc is one that is larger than 180 degrees. So the inscribed angle is lying inside of the major arc here, okay, that's highlighted in blue and that I'm re-highlighting in pink, okay. Okay, now there is another corollary to this that we actually are going to put in the notes. So take a look at this question. If the measure of the central angle is 180 degrees, what would be the measure of the inscribed angle? So we could talk about the central angle, we could also talk about the arc, but basically, okay, this measure right here of both the central angle and the arc is 180 degrees. We know that the inscribed angle always has to be half of the central angle or the arc that it's intersecting. So half of 180 is equal to 90. Which means that this angle right here is a right angle, okay? And this is actually a corollary to the theorem we just talked about. So angles inscribed in a half circle will always be 90 degrees, okay? And here's a couple of different examples. So anytime the inscribed angle, what you really just need to look for is if your inscribed angle is connecting to a diameter, like it is in all of these examples, then that means that that inscribed angle is 90 degrees. So basically, you know, these are all right triangles, which can come into play in problems sometimes. Sometimes they'll try to get you to use the fact that this is a right triangle. And then you have all those right triangle theorems that we've learned about in the past. Okay, so let's put that into the notes. Okay, at the very bottom. All right, so we'll put mark our little like new box, and you can call this a corollary. C-O-R-O-L-L-A-R-Y, corollary. Okay. Angles, and then kind of leave some space over here because we're going to draw an example, but we can write to about here. So angles in a half circle are always, oh shoot, I did fix angles in a half circle. I want to say inscribed in a half circle, not just in a half circle. Sorry guys. Angles inscribed. Inscribed in a half circle are always 90 degrees. Okay. All right, and over here we'll put our example. So mark your center of the circle if you can. You know, if you have to just estimate, that's okay. It doesn't have to be perfect. And this circle didn't turn out perfect, but that's okay. We'll go ahead and draw a diameter of some sort. Okay. And then our inscribed angle inside of that diameter. Okay, so it touches the edge of the circle and connects to the endpoints on the diameter. Okay, so let's call ABC. Okay. And that angle right there is 90 degrees. Okay, so you could say AC is a diameter. Okay, angle B equals 90 degrees. Okay. And remember that this is because the central angle and the arc that it's intersecting is 180 degrees, and half of 180 is 90. Okay, I don't want to make this video too long, so we're not quite done yet. We still have one more thing to talk about, which is inscribed quadrilaterals. But I don't want to make this video too long, so I'm just going to pause the video or stop the video here, and I'm going to make a new video. I'll put them in order on the playlist, so if you're watching the playlist and you want to go ahead and go to the next video, you can. You can take a mental break right now. Is a good time for a little mental break. Get some water, do whatever, and I'll see you in the next video.